Good afternoon, or good morning, everybody, depending on where you are. My name is Damon Bassetti. I'm a program manager here at the Design Lights Consortium. And thank you for coming to our technical requirements webinar explaining our first draft of our horticultural lighting specification. There are a few other DLC staffers here on the call with me, and we're all pleased to have you here with us. Some housekeeping before we begin. Don't worry about preserving the slides or taking screenshots if you don't want to, if you only want to focus on actually listening and participating in this. We're going to be posting these on our website after this presentation. To avoid any unfortunate audio interferences, we've gone ahead and placed everybody into the mute mode. So if there's any questions that you want to ask, please go ahead and type them there. Oh, pardon me, everybody. All right, now I'm sharing my screen. My apologies. All right, yeah, so here we are. We got the slides shared up on the screen and going through some housekeeping topics. Okay, so we're gonna be posting the slides onto our website. Please, if you have any questions, post them onto the question pane. And we have people watching it and they'll be answering either individually or to the whole group as the question requires. And we'll also address key questions that come up at the end during a kind of discussion section. And this is not the last time I'm going to say it during this webinar, but I wanted to make sure that we get this locked into your brains. Comments on the first draft of the specification are due by May 30th, 2018. It's a nice long 45-day comment period to give you ample time to think about this important and technically complicated specification. New this year, we are going to be asking everyone sending us comments to submit them through an Excel-based comment form. If you've worked with us in the past on our network lighting controls comment forms, these will look familiar. Now we're using them in this area as well. We've placed it alongside all of the draft specifications and the key technical questions documents on our website. And this will help us keep everything a little more organized and hopefully make sure that we are considering every single piece of feedback equally during the comment review process. So here's our agenda for today. I think we got the welcome completed. I always want to go and reiterate again, thank you to everyone who's here. I was looking at the attendee list. There are many names I've grown to know and many more that I'm excited to be able to get to know as we work on the specification and get it finalized. You've given us a lot of your time and knowledge and experience, and we really do appreciate your cooperation with us to make this as impactful and positive as possible. We always love getting feedback on the spec. That's why we're doing this meeting with you and by more formally through that comment form on the website that I just showed you. Today, we're going to be reviewing the specification, also reviewing DLC and its purposes. Then we're going to be kind of highlighting some of the key questions that we kind of took a shot at things that you might be thinking, having read the spec, and maybe explain some of our thinking behind them or some of the pinch points that we might be aware of. And yeah, then we're going to be opening up for Q&A and commentary from the audience. All right. As a very brief review, there are some people for whom this is a lot of review, but there might be some people who are a little bit newer in working with the DLC. So I wanted to go ahead and do a kind of where we stand in the world. What I tell people is that DLC makes tools and stakeholders use them. Utilities, for example, are responsible for how their incentive dollars get spent and making sure that what products get incentivized, what products don't get incentivized, raises questions of quality, of efficacy, and that can be time consuming and lead to a lot of duplication of effort if every single utility needs to independently answer that question for a product. So what DLC does is we have these lists. We have one for lamps and fixtures and one for network lighting control systems, and hopefully soon we'll have one for horticultural lighting products. And we gather experts from all over industry, academia, utilities, national labs to figure out what the criteria are to get on those lists so that when a utility chooses to incentivize something, they can show that they are being prudent to their various stakeholders themselves, and that the products will give the energy and other performance outcomes that they need to. That saves them time, And this gives everybody kind of one standardized specification to build to. But a really nice, cool thing happens when there's a standardized database of product performance that's publicly available, like we've seen with our other lists. Lots of other kinds of people, not just utilities, start finding value in that. From manufacturers who might be doing market research to distributors making stocking decisions. We see all kinds of people using our lists every day for all kinds of reasons. And that makes us excited because the more accessible and easy to access information that there is out there, the market transformation is going to accelerate. And this equipment and technology will get adopted at higher rates than they otherwise would have been, because this helps reduce friction in the acceptance and uptake of these products. This is a lot of words, but the short version in how we go about making these lists is that we do lots of talking, but even more importantly, we do lots of listening. We go out and talk to and listen to people from all over. And once we feel like we understand the needs of a potential policy, what it might look like, we take it to our stakeholders. These could be industry advisory board, manufacturers of various types of products, to our utility members, and to other stakeholders in this world. After getting their agreement and their thoughts on the topic, we dive on in and begin working on a bunch of different drafts and policies and potential products. Stakeholder input is critical to all of this, and this is where everyone on this call comes in, and where you have been coming in so helpfully. So I want to say thank you again to everyone who's been so generous with your time over the last year or more as we've been working through this flowchart that you see on the screen. Unfortunately, I do have bad news for you. You haven't heard the last of us yet, and there's much more commentary to be made, and we can't wait to hear it from you. But we're getting close. Are we there yet? You might be thinking yourself. We're pretty far through this flowchart at this point. We've been doing a lot of work over the last few years to understand horticultural applications and the need for a specification. We've begun participating in industry standards groups like ASABE ES311, key highlights of which are the S640 document published last summer. We participated in a DOE, Department of Energy, horticultural lighting roundtable in February, Nashville, Tennessee. And we just last Friday released our first draft out for public comment. Now, because this is so technically interesting, you might say, we are definitely planning for having 2 rounds of draft commentary. The first one's a 45-day comment period. The second draft and comment period will be a shortened 20 or 25-day comment period that closes in the middle of August in 2018. We're aiming to have the final specification published in September of this year and have products available for qualification right away. All right, let's get through the specification itself, the thing that you probably all came here to learn about and talk about. And I'm just as eager as you probably are. We initially had been thinking about a 2-axis spec in which one axis would be output, another axis would be application, full replacement and supplemental, and high output and low output. But we began to realize that there was no bright, technically defined line that we could draw to distinguish between lighting products for sole source and supplemental applications. This was especially confirmed by manufacturers. Sole source applications tend to use high output lights because they have to replace the sun, which our top scientists assure me is very bright. Supplemental applications tend to use low output lights, but the variables within that space of, what are you growing? What is the daily light integral or DLI that the crop needs? What USDA climate zone are you in? What is your cloud cover throughout the year on average? And what cultivar of the crop are you growing? That makes dividing this nice, neutrally measurable line really difficult, practically impossible. And so we went ahead and decided to go with just a high and low output breakpoint. We are proposing in this first draft of the specification to make that breakpoint between high and low output at 300 micromoles per second, measured within the PAR, or photosynthetically active radiation range, 400 to 700 nanometers. That is to say, within that range of 400 to 700 nanometers, the flux coming out of the light fixture will be either above 300 micromoles per second or below, to be in those 2 categories. But before we go too much farther, let me take a moment to have a word on PAR itself as well. So PAR was defined last August by the S640 document produced by the American Society of Agricultural and Biological Engineers ES311 committee, is the foundation of the specification. Because, especially for DLC, without industry-approved ANSI style standards, drawing lines for performance minimums is very difficult to support. And so we love the fact that standards committees are working on this and still actively working on it. And that's what we are going to rely on because it's neutral, it's accepted, and there's no concerns about impartiality because it goes through the ANSI consensus process. Even though we are relying completely on PAR as the kind of bright point for all of our hard decisions, we are not asserting that PAR is the only thing matters for growing plants. Far from it. We would assert that it seems pretty important. If you could successfully grow plants without any PAR, I would like to hear how you are doing it because that sounds very interesting. It seems to be a major component of the total photon flux that needs to be going into a plant, but we acknowledge and understand that there are other wavelengths that are still important for various metabolic and also signaling and environmental sensing needs that plants have. So how do we balance those when we're making our decisions about where to draw lines and define boundaries? The first question we ask is, what is the most PAR efficacious way to make light for these plants with solid state lighting sources relative to the incumbent sources that growers would have otherwise used? And this is a pretty big energy efficiency concept, is what is the incumbent or base case application or technology that you are trying to replace? Correspondingly, we also don't want to set that so high that we crowd out any kind of experimentation with what I've taken to calling XPAR, that is 280 to 400 nanometers or 700 to 800 nanometer light recipes, or just various needs driven by crop diversity, depending on the grower's economic constraints, climate constraints, crop constraints. One could imagine needing to leave some amount of energy budget that's not just focused on PAR for any one of these situations. And you might be wondering why those numbers 280 are there and 800 are there. ISABE ES311 S640 has defined the quote full range of photosynthetically or photon flux that's relevant to plants as being in that larger, wider band. So photon flux, which is PF, is 280 to 800 nanometers, and photosynthetically active radiation is a subset of that, 400 to 700 nanometers. So here is a table that we are, if you've looked at our specification or draft specification we've published, this will probably look familiar, but here are all the different variables. So you'll notice that we are differentiating among different products based on the photosynthetic photon flux, PPF, or PAR. Again, high output devices greater than or equal to 300 micromoles per second, low output devices less than 300 micromoles per second. And again, we're considering that 400 to 700 nanometer range or bucket for counting that. However, because we understand that knowing more information about photon flux is important for a range of different users, growers perhaps, specifiers, distributors, engineers, we are also going to report on the total photon flux across the 280 to 800 nanometer range. So you'll have two flux numbers for the products. One could imagine if a fixture had lots of non-photon flux or non-photosynthetic photon flux and more photon flux, you actually might see significant difference between those two. So we will see. Next is the spectral quantum distribution, or I like to call it SQUID, and that is the kind of wavelength distribution of your total flux. So flux doesn't actually tell you what wavelengths. You could have something that's very green or very blue or very red, and it would look by a PAR filter to be all the same. That may or may not be necessary or what a grower needs. And so if you need to know more about the composition of your actual flux coming out of the fixture, that's what the spectral quantum distribution or SQUID will give to you. So we will be asking to see that as well, and we'll be reporting on it in some form with our QPL. Next is the photosynthetic photon intensity distribution, or PPID. It's not very pronounceable. But that is analogous to some aspects of what we in the regular, I guess, human-based lighting world know as the IS file. This tells you what light is leaving the fixture at what angle, and will let you begin to do things like simulations for, if I lay the fixtures out in a certain arrangement, what will be the balances of light on the floor. One other note here, as we're talking about 400 to 700 nanometers and 280 to 800 nanometer range, the test labs that we've been speaking with, who would be the people generating all of the various photometric files, verifying and measuring and quantifying performance, are able to accurately and verifiably measure with integrating spheres and goniophotometers within that PAR band. That's a known quantity for them. But it seems that they have never really needed to do the same in a single test across that entire Asabe S640 range, 280 to 800 nanometers before. It's not really a problem for this because we're not making an enforceable hard line based off of that data. We're only reporting it. So while we will require certain accuracy and precision bounds for that PAR range, for the overall photon flux range, we will not. However, we are working with the labs to begin a process of that same accreditation and round robin testing and verification efforts started for that larger, wider band, because it is conceivable that the science may evolve to make this more important, or more verification of performance in that range much more important. And so we want to make sure that the scientific and testing infrastructure is ready to test it impartially and accurately. The big number on this slide is the photosynthetic photon efficacy, or PPE. This is in the micromoles of output in the PAR range divided by the input joules of energy to produce that flux. For both high output and low output devices, we are proposing in this first draft to set it at 2.1 micromoles per joule. The reason for this number is that it's indexed to the kind of best-in-class horticultural lighting product that we could find on the market, which is 2.1 micromoles per joule, to our understandings. We'll have more on this later, but you might be thinking to yourself, why are there two categories if you have the efficacy requirements to be the same? The reason is that the incumbent light source for each is different. In high output devices, the incumbent light source is usually some kind of a high intensity bulb, which is metal halide or high pressure sodium. Low output devices, the incumbent efficacy is usually a different technology, sometimes fluorescent tubes, sometimes compact fluorescent, sometimes even incandescent in certain applications. We'll talk more about what that means for these later on in our key questions section. But that's the efficacy breakpoint where it must meet or exceed that efficacy. For flux maintenance of the PAR radiation, we are again making a threshold that the flux must degrade by no more than 10% within the first 36,000 hours of continuous operation of the fixture. There's a couple different things there. So it's Q90, not L90 or L70, as many in the human-based lighting world have come to use as a kind of benchmark. The reason for this is L stands for luminous degradation, and lumens are not what we're talking about here with horticultural lighting. We're talking about flux of photons. And so in the engineering symbol, for example, that Asabe uses in the documentation for S640 is Q for flux. So just another little thing that's a little bit different between the two worlds that I'm sure we'll all get used to. And how did we pick 36,000 hours? That was that lets us use the same kind of testing and extrapolation tools like TM21 that we've come to rely on for human-based lighting. And in talking with growers, both of cannabis and non-cannabis crops, that 10% flux degradation at 36,000 hours seems to be the point at which the burden of replacing fixtures is outweighed by the decreased flux degradation or the decreased photosynthetic activity in the plants. So because plants are much more sensitive to things than the human iris, or the pupil, which can open up. Plants, if you give them less light, they simply grow less quickly. So if a product keeps decreasing in its flux, the tomatoes will grow more slowly and not help the greenhouse owner make their mortgage payment on time. So this is something they're very, very sensitive to. So that Q90 is a par flux degradation threshold for par. We're also going to ask people to report for a fixture the time to Q90 for the overall larger Asabe band range as well, in case that is of interest. All right, so let's go into some surveys. So having gone through all of these different stats and thresholds and breakpoints, we, and by we I mean our DLC's capable technical support contractor, DNR International, did a lot of market research in coming up with the justifications for this. We studied, I think, over 400 different fixtures, anything we could find basically, talking with manufacturers, finding things online, combing through Department of Energy reports. And here is what we saw. And so this is a chart of the flux on the vertical axis and the wattage on the lower axis. That red line is at 300 micromoles per second. So everything below that would be are considered in our low output category, and everything above that would be in our high output category. Next is the efficacy chart. And so for PPE, or photosynthetic photon efficacy, the red line represents 2.1 micromoles per joule. And as you increase in power, it seems that it gets harder and harder for products in the market to exceed that, which makes sense if you understand how thermal buildup at the LED device level usually tends to be the thing that causes droop in efficacy. And as things run cooler, they run more efficiently. So lower output seems to have less difficulty hitting that efficacy bar. Finally, here's some more specification requirements. Warranty, going to be asking for 5 years as a threshold requirement. In the terms and conditions, we're not going to be too specific, but we would like to see, for example, no kind of gotcha limitation. So if something is meant to be sole source, then there should be a reasonable amount of daily hours used that would not disqualify someone using it for a commercially reasonable sole source usage rates. So I think for sole source, that would be 18 hours per day. We would expect to see at least covered by that warranty. For supplemental, we'd expect to see 12 hours per day usage covered for that 5-year period. For power factor and total harmonic distortion, these are pretty similar to the existing DLC specs for products, 0.9 and 20%. And then for safety certification, there is not yet a standardized, I guess, ANSI accepted certification yet. However, there's progress being made towards that. For example, we're seeing labs for standards that are more or less aligned to the UL 8800 standard, which I would paraphrase as being UL 1598's general illumination, but with moisture and corrosion complications. However, there remains to be complete harmonization. We do know that other testing labs do have interim designations that are more or less compliant with that. And once that final kind of harmonization and acceptance to the ANSI process happens, we will go ahead and officially rely on that. Until that happens, we will work with the nationally recognized testing laboratories to understand how they will rate horticultural products and then require them per each lab's own internal designation processes. Finally, for power mode, we are proposing in this first draft specification to have AC line voltage to be the only approved means of powering fixtures. We did see some commentary from some of our stakeholders that we might want to consider opening this up to things like DC, direct current, or power over Ethernet. There just did not seem to be very much of a market presence in this period. And the technical complications of assuring performance and efficacy for these alternative power topologies did not seem like it would add a lot of value here. However, we don't want to preclude that, and especially as we gain more experience with DC and PoE and general lighting, as you will hear about in our webinar tomorrow. We would be happy to open it up to those as we gain more experience and confidence working with those, both within DLC and also as a larger industry. We would also really like to see some kind of a standardized labeling scheme, perhaps on specification sheets for products, similar to what you might think of when you see think of a lighting packs label. We are aware here at DLC of a few different alternate proposed labels that are circulating. We'd love to hear about those and others and the drawbacks and strengths of each. And we would love to see something emerge as something that could be standardized upon, because a nice, quick, easy to glance over label at the customer exposed level goes a really long way towards reducing friction. And if we can point to that as a standard or a qualification for being on our list, then we would love to add that incentive. Spectrally tunable is an interesting thing. We did not see that very prominently in our market research, but we did see some products. So we would like to try to standardize the way in which the varying spectral presentation, the varying fluxes achievable through spectrally tuning of different channels on the light fixture could be displayed to end users. And so what we will be proposing, what we have proposed in the specification, is to show information about the fixture performance in the all-on mode at its maximum output. And then if there were, say, 3 different channels, say red, blue, and white, test with blue to the maximum and red and white to the minimum, display information on that performance level, and then repeat that for the other 2 channels. So this way you could show end users and people doing product selection what the range of achievable fluxes are out of that spectrally tunable product. Finally, the last specification that I've highlighted in this table is cooling fans. These are cooling fans that are built into the light fixture to help keep the power supply and LED device temperature within acceptable parameters. As I alluded to before, thermal is usually the big single reason that causes end of life for these products. And so, especially given the small physical footprint, if you want to avoid shading, for example, in a greenhouse, combined with the high power and high flux, does create a pretty challenging thermal environment for these products. I think in our background market research, we saw that 30% of fixtures in the market that we could find did have some kind of active cooling fan built into it. So, and that's a much higher rate than what we've seen in, for example, high bay lighting, which is a kind of similar form factor in the human lighting space. So we don't want to ban that, but we do have some concern about adding another kind of lifetime limiting critical component to these products. And so, on consultation with a couple very knowledgeable stakeholders in DLC, thank you again, we are proposing to allow them with documentation similar to how we do with third-party OEM drivers for products, that the manufacturer spec sheet that is provided to the fixture manufacturer asserts or lists that the fan has a mean time between failures of at least 50,000 hours. We think that'll be a good balance of managing risk and performance, that the fans will not be the reason for fixture failure. Okay, we have some bunch of questions coming in. Dave is busily working on them, and we will surface anything that he can't get to or answer by the time we get to the end. But thank you. I'm really glad that everyone is asking questions, and that means you're staying engaged and thinking, and we're getting reactions from you, and it's exactly what we need. So I will keep motoring on while Dave handles those raised hands and questions. And thank you, Dave. All right, so here's the key questions, Doc. So along with our requirements that we released, we also released a kind of memo saying, hey, here are some questions that we have that we would like those commenting on these requirements to answer for us in their commentary. And they're probably things that you would find yourself commenting on generally, even the edits to this document. So the first key thing is, it's almost like a sanity check. We want to make sure that we are considering any and all industry efforts that are already underway, because the last thing we want to do is duplicate work or duplicate effort. And so these are like things like how Wasabi is standardizing terms and definitions, labeling conventions. I spoke about that recently. For example, IES is also, we've heard that there is a draft standard to help adapt the current kind of human vision based data file format to accommodate non-lumen products, things where PAR is more of an importance than luminous flux. And then that kind of testing, round robin testing I'd alluded to earlier as well. So these are all the things that we know about up on the screen. So we want to make sure that if there's anything we don't know about that is germane to these questions or anything else really that groups are undertaking, we would like to know about it, please, so we can make sure that we're all pulling on the rope in the same direction. Next up is the fan question, really. So we're specifically asking, do you think that we should allow products with fans on a qualified products list? And if so, what would be useful reliability requirements? For example, driver failure could also be a limiting lifetime factor for these products. And so for DLC Premium, general illumination side, we require certain characteristics of the drivers, that there needs to be a temperature measurement test on the driver, and then there needs to be documentation from the driver manufacturer that showing that the driver, when operated at or below that temperature that's tested, will have a certain lifetime. So that combined with the chip level reliability or LED device level reliability statistics like TM21 gives a higher level of confidence in the product's overall life cycle. Notice that we asked about fans, and we did not ask about externally ducted cooling air or liquid-based cooling loops, both of which are, I don't want to use the word, they seem to be less prevalent than self-contained fans on fixtures. And they are probably very perfectly valid ways of moving excess heat out of a fixture. However, when it comes time to operate that fixture in a steady state inside a spherical integrating sphere or on a moving goniophotometer, making sure that your cooling air ducts or coolant loops are not moving around or leaking or flopping on things seems like it would be extremely difficult to make that product uniformly and repeatably tested. So if you were to take that product and do it in 3 different labs, we don't feel confident that you would not get 3 different results because of the difficulty in managing all these kind of external attached parts. So we are only proposing to allow fans and not those other 2 cooling methods as well. Another question that we have about lifetime and reliability does have to do with the LED device level. There are 2 different ways that you could probably make a guess or make an estimation of the longevity of a product. You could go and build up from the component level on up with LM80 and TM21 like we do with general illumination. Or you could take the final completely assembled fixture and run it in a test chamber for a certain amount of time, 6,000 hours or so, and then make an extrapolation for that fixture. LM84 based methods or similar ones do tend to give you higher certainty that the whole assembly will perform as your data indicate. However, that's really expensive and can slow down product introduction, because if you have to test a single fixture for that long before you can actually even sell it on the market, that's a certain level of challenge and testing burden. And our question is, does the faster, simpler, albeit perhaps less tied to reality extrapolation of LM80 and TM21 give us enough certainty? Some people we spoke to thought that was fine. Other people that we spoke to felt that the increased harshness of the horticultural environment, humidity, potentially corrosive chemicals, etc., might make it more valuable to us to require LM84 testing. or something similar as well, especially given the increased sensitivity of plants to decreases in flux versus the human eye. So we would love to have feedback from you on this, and especially with as it relates to data on reliability and lifetime and longevity. Commentary is fantastic. Commentary with real world fleet longevity and life cycle data that you may have collected or have access to is even more fantastic. So we would love to have as many technical justifications and requirements for your commentary on this as you could possibly manage and collect, and that'll help us make the best decision. The next question that we are asking is, are we doing the right thing in splitting the output categories into high and low? I mentioned before how the application-specific breakpoints, once you start thinking of all the different permutations of all the different variables that could exist, it starts to get messy. And so it seemed that having a simple, easy to understand designation for this first draft, for this first wave of the specification, which will inevitably be revised in the future, would be enough for now. Close to plant and far from plant seem to work best. But tell us what you think. And next is the efficacy requirement. Like I said before, we're trying to run a balance between technically achievable PAR efficacies, but also letting room for light recipes, XPAR usage, and crop diversity, and grower diversity, and economic diversity. The thing here that really gave us, that we had a lot of conversations about, was the incumbent efficacies for high output were essentially HID or HPS, which had the highest incumbent efficacies of around 2.1 micromoles per joule. That generally with SSL is the most challenging kind of efficacy with that high power density and a low surface area product. The heat that you're managing is difficult. And if you can achieve that efficacy in that package and footprint, then it seems it would be at least as achievable or manageable to achieve that same efficacy in a low output package, where if you're doing vertical farming, for example, you have flat, wide fixtures that are inches away from leaf lettuce, for example. However, we understand that in those latter applications, low output, the incumbent technology is fluorescent, usually with around 1.0 micromoles per joule. And so, yeah, we want to hear from you on the balance between achievable efficacy, incumbency, and allowing for an energy budget for other variables as well. And finally, for spectral tuning, are the proposed tests, multi-channel testings that I described before, are they achievable? We understand that if you have a 3-channel system, then we're asking then for perhaps 4 tests that are similar to LM79 or equivalent. That is 4 tests, but there is a really well-educated customer coming out of this who understands a lot more right off the bat from what that product can do. We think that's a useful and worthwhile outcome, but we want to hear from you as to what you think about that. I just want to make sure also as well that we're not going to be considering dimming along a single axis from you have the fixture and you can make it brighter or dimmer, but all of the LED devices on board will be dimming and brightening at the same point. We would consider that to be dimming, and we might report that separately as a kind of basic product feature. This would be for multi-channel dimming, essentially, to produce different spectral flux mixes and outcomes. The key question here is, this is a complicated question, or a complicated topic and application. The science of what mixes of flux to give to your plants is certainly rapidly developing, and I'm not sure completely understood at this point. So how can we set a really good kind of expectation of common communication on what a product can do so that customers don't get confused, and that the market can understand, and when the science advances and evolves on the different mixes that are being tested, they will then be able to take that knowledge from the lab and put it into practice in the field with a minimal amount of friction getting in the way. All right, I'm going to do a quick summary, and then we will have some time for discussion, questions, and answers. All right, so last Friday, we released the first draft. In July, coming up, we're going to have our stakeholder meeting here in Boston, and we're going to be having some activities around horticultural aspects as well. And so while if you can't make it, that does not mean you will be locked out of the commentary process, because our door is always open electronically and virtually. If you can make it, that might be a good conversation, a good opportunity for some more conversation as well. The second draft that we're going to process after all of these commentary periods close up and our in-person conversations at the stakeholder meeting will be released in July, and the commentary period for that will be closing August 15th, 2018. And then in the gap between then and September, we'll be working on the final specification and getting all of the website infrastructure ready and up to speed. So the list and applications will be all online on the DLC website. And thank you for your time, presence, attention, and help commenting on this and helping teach us everything that we've learned so far about this exciting world. David Ryan, DNR International, the DLC technical support contractor, and I are their main points of contact. So please don't feel shy about reaching out to us. Dave, I suppose this is our question and answer period now. Are there any questions that you think should be highlighted or we have not been able to get to answering yet in the questions pane?
Yes, I want to thank everyone for their very active engagement on the question pane. One of the benefits of having everyone write in on the question pane is we do get automatic written records of those questions. So I think it will be useful for us in developing, for example, some clarification FAQ that may help everyone over the next few weeks during this open comment period. So Damon, there's a few that I think are probably worth you addressing or re-articulating what you went over in the slides already from the questions that are coming in. The most common question we're getting is if you could reiterate the sort of focus and considerations on the requirements respecting the PAR range, 400 to 700 nanometers, and the XPAR range in the broader considerations, the 280 to 400 for UV and the 700 to 800 for sort of far red. There have been a number of comments or questions about, well, plants often need or do specifically need light outside those ranges. How is that being considered? And so I think it's probably worth if you sort of re-articulate what our current thought processes there are. And also just to comment to everyone, and I've been addressing this individually in the question pane, but we are very actively seeking commentary on this. So this is a starting point for our conversation, and so we do appreciate there's a lot of differing perspectives and complexity in trying to get this spec right.
Great, thank you, Dave. That was really long, and I will try my best, but please feel free to jump in to redirect me if you see me drifting. The basis for everything is in terms of standards-based. I guess we rely specifically on standards-based definitions. And so to the extent that the SABE ES311 S640 defines the two ranges, 280 to 800 nanometers, and then the smaller 400 to 700 nanometer PAR range, though that's going to be the bulk of what we're relying on. We have definitely heard, I'm sorry, Dave, could you please mute yourself? Your typing is very vigorous.
I'm so sorry. Yeah, bye.
No problem. Sorry, everybody, I'm easily distracted. We've heard definitely from stakeholders that there are other wavelengths outside of that 280 to 800 nanometers. We heard that certain cannabis approaches require even far IR, like something in the 1120 or 1150 range. And the person who shared that with me probably knows a lot more about that than I do. And so we're definitely not making value judgments on this. We are staying within the bounds of industry accepted consensus in terms of making something testable and required. And to the point where we're actually making something a required filter where we say you shall have this for a certain property, then we have to stay within what is uniformly and repeatably testable at the range of varying test laboratories that'll be generating the reports that we rely on. So those reports can only really be reliably generated right now in the 400 to 700 nanometer range. Efforts are underway to expand that range to the full 280 to 800 nanometer range. That is not to say that once those round robin testing and verification efforts are complete, that we will switch and require everything to be in the 280 to 800 nanometer range. I think we will probably follow the lead of other standards bodies that know much more about plant biology, groups like GLAZE, everything happening at the LRC or LISA, or LIDA, sorry, and other kind of academic research institutions. But I guess so to wrap it all up in a kind of meandering way, where we are most strict is where it is most defined and most repeatably testable. Where it is less understood and repeatably testable, we open up the capability to report on characteristics. So, for example, there are no accuracy or precision bounds that we're asking on that larger expanded 280 to 800 nanometer range, because we understand and expect that there might be more variation than we otherwise would have liked amongst those doing the testing. And so that is merely informational best effort reporting as well. To the extent that there are wavelengths outside that PAR band that are important, they will be covered in both the reported 280 to 800 nanometer range. And I suppose that if there are things that are even beyond outside of that, then that'll be reflected in the energy budget. So, and that 2.1 micromoles per joule that's total joules input to the device, making all kinds of wavelengths, but we're only counting the output wavelengths of PAR. And so if tomorrow it was to be found that a certain wavelength outside of the Asabi range was critically important, but was not uniformly testable, one outcome might be that that energy budget might come down so as to allow for more photons to be emitted in that wider area that we cannot reliably measure at this point in the fixtures. Dave, was that wordy enough? Do you think I addressed the question, or should I go in a different direction?
I think that was good. I'm honestly trying to balance responding back to the queries that are coming in as well. So that is sort of the overview of what our current thoughts are. I want to reiterate that we are looking for commentary on it, and if you don't feel that we've clarified what our intent here is clearly enough, or what our thought process is clearly enough, let us know through an email to info@designlights.org, and we'll see what other additional clarifications we could put out to make everyone comfortable on that. So there are a number of other questions, Damon. I think we have a little bit more than 10 minutes here. I think it may be most worthwhile to just walk through them one by one and address them as best we can. We may be able to push a couple minutes over time, but trying to respect people's time. Anything that we can't get to, we'll try and loop back on offline off this webinar. Does that sound good?
Sounds great. Let's go.
All right. So there's a question on what the ideas behind the warranty requirements are for sole source lighting versus supplemental lighting. What the distinction between the warranty requirements are and what is driving them. Do you want to speak to that?
Yeah, sure. This is pretty simple. The idea is that if you look at the average light that is in use in a non-horticultural environment, it's probably not on all of the time. Even a light in a store is off for 6 hours, if not more, overnight. The average A19 bulb is probably on 3 or 4 hours a day. We wanted to make sure that growers using these products felt confident in the terms of their warranty would be covering them in the typical application methods or metrics. The increased operating hours of 12 or 18 hours per day that are associated with either supplemental or sole source lighting should be, because growers should not be excluded or have their warranties revoked for using them in commercially reasonable ways. So that's what we're looking for in the language on the warranty there.
Great. So there is a question directly about why we would propose to allow products with fans. And the comment here is that fans are for sure to be the first point of failure. So I wonder if you want to give some commentary on that.
Absolutely, thanks. Well, I don't want to give any, I guess, assent or dissent from the assertion that fans will be the first point of failure. We certainly are keying in on them as being a potential significant source of fixture failure, for sure. If the fan breaks, the LED devices and driver will get too hot and then they will die or fail early on in their lifetime. There's no doubt about that. That being said, the high aerial power load, especially driven by the high output fixtures that you see in the market for sole source top grow applications, does seem to impose a certain kind of volume penalty on the products, and that makes the usage of fans more prevalent than otherwise elsewhere. Right? More prevalent than elsewhere. And so it seems it would be a very kind of large step for DLC to take to disqualify what seems to us to be about a third of the market. If one feels that fans are inherently limiting in performance, then that might still be a competitive differentiator for someone who is more worried about that than the others. And so, again, DLC is not making any claims about what is more worse or better, more or less efficacious or better performing. Our goal here is to set basic standards of performance, reliability, and energy consumption relative to output, and then get out of the way and let purchasers, designers, growers make the best decisions as to what's right for them. So we think, based off of the output we've had with some experts in reliability engineering consulting, that setting the MTBF for fans in an actively cooled fixture at 50,000 hours will mitigate that risk.
And I think the only color that I might add to that, Damon, is we know that fans are a potential source of failure, but other components certainly are as well. So as much as we're addressing long-term performance of LEDs through something like the flux degradation or the long-term performance of the driver, which is another common point of failure through driver ISTMTs and driver lifetimes and operating temperatures, we were trying to figure out a sort of technically rigorous way to assess, how likely the fan is to fail. And so, as with everything else, we certainly welcome commentary on that topic.
Exactly. Thanks. Yeah. So for the things that are most likely to limit the life, we want to have similar assurances of longevity. That's all we're going for.
All right. There are some questions about the testing limitations. There's some notes on some common sphere pieces of equipment for integrating sphere testing may only have precision down to something like 350 nanometers. I know you addressed that in the presentation, but I wonder if you could sort of comment again on the concerns or the conversations that we're aware of on precision in testing, particularly in that short wavelength range of the overall range.
Yeah, thanks, Dave. Yeah, we are totally aware that of the varying accuracies at the long and short ends of the range that we're talking about here, which is why we're not making distinctive required or threshold measurements based off of those. We are talking with the labs, and we do feel that there is a path towards getting the industrial testing infrastructure in place to accurately measure those things over time. And so that's why we're allowing reporting of that values or variables there. And it might even be appropriate for us to have some kind of disclaimer on the full PF range, so people don't put unwarranted confidence in that. But yeah, we're totally aware of that, and that's why we're not making hard distinctions based off of those data.
All right. There is a question on, for the spectral distribution, what resolution would we be requiring? I think that is in the spec directly itself, if folks want to reference it, and we're certainly interested in commentary. But at the moment, I believe we're proposing a 5 nanometer resolution. You want to check me on that, Naaman?
I believe so. Or no coarser than 5 nanometers.
All right. There is a question on whether DLC intends to incorporate premium requirements versus standard requirements the way we have on general illumination.
I think that is probably not for this first instance of the specification. However, as this marketplace matures and we get more experience, more products out there, the same forces which led to the need for a premium versus standard in general illumination may also emerge for this area as well. So I don't want to rule it out for sure, but it's not something that we're going to be proposing for this wave.
Great. So another actually section of questions here, sort of a group of questions, is asking about particular details in the testing protocol, sort of noting differences between the general illumination focused standards LM79 or LM80 versus the sort of specific needs in a horticultural environment, and wondering how we might be thinking about bridging those gaps. This is, there's many things in process, but do you want to comment on sort of what we're aware of and what the current constraints and thought processes are?
Yeah, absolutely. So the big spec that is we're very excited about being almost available is another work product from the Asabi ES311 committee, and it is working on defining adaptations of the IES-defined lighting tests for horticultural specific products and environments and circumstances. And we expect and hope and are actively participating in the committee to encourage this, that this will, and make sure that this will happen, that these will be published and completed very, very soon, imminently. And so hopefully we'll be able to speak a little more confidently about what those testing requirements will be. But it's there, it's technically achievable, and there's a lot of work that's been put into that process.
Okay, great. There are some additional questions. I know you addressed it, but maybe you want to talk again about systems that incorporate liquid cooling or other types of closed loops thermal management systems.
About our reasoning for it, proposing to exclude them?
Yeah, the question here is, what about completely integrated systems? So maybe sort of reiterating what the current proposal is.
Yes, I suppose the proposal considered 3 different kinds of cooling systems. 1, actively cooled fans that were built into the fixture. 2 would be external cooling loops, basically small lines carrying a fluid that circulate through it and then go out to some kind of external radiator or heat sink. And 3rd would be some kind of a duct that passes conditioned air over some or all of the fixture and then carries that warmed air away. Am I to understand, Dave, that the question is about perhaps a fixture that has some kind of sealed liquid system on board that is not being carried off board and cooled?
Unclear. I think we can probably loop back with this
Okay.
commentator directly, but I think the overall question is on these, liquid cooled systems and things that may have a closed loop.
Right. Okay, yeah, so generally speaking, the current test standards that are based off of things like LM79 don't really have very good accommodations for bringing a liquid line into the sphere or onto the goniophotometer stand. So when those standardized test approaches can accommodate those, then we're happy to accommodate them in our standard specification. because that means the data that comes out of those tests will be supported and reliable and repeatable and accurate. Until then, we're not really that confident, unfortunately, that every lab will do everything the exact same way.
All right, there's a question here on the focus on metrics between photosynthetic photon flux and photon flux density, and sort of explaining the reasoning and determining which metric we would focus around. Do you want me to take a crack at that, or?
Let me try first, then you can lifeguard me. How's that?
Sounds good.
All right, so this is kind of similar to the difference between lumens and foot candles. The ppfd is the density of par radiation on the floor per square meter per second, and is a variable that depends on how far away the plants are from the lights or the fixtures, what the geometry of the building is, what color the paint on the wall is, a bunch of other things. And you quickly get into a huge complexity, a huge set of complex permutations of different scenarios that would be very difficult to be meaningful to the average user. And so what we're trying to do is to set the, with the data that we're asking for, the flux, and then the, let me go back to my other acronym that's hard to pronounce, the photosynthetic photon intensity distribution. You can take the data files, similar to IES files for these products, and then place them into your specific situation you're trying to understand. And then from that, derive the ppfd for your specific geometry. There is some thought about setting up a kind of reference application and then laying it out and saying, all right, well, for product X in reference geometry A, your ppfd would be Z. But that does not seem to be both either practical or useful to the wide variety of users from our own interviews. Dave, what else would you add to that?
So I think the only things that I would add there are, it's difficult to know with certainty exactly what the lighting design choices of a given installation will be. So assessing things at the product level versus at the layout level, we feel like is a generally more prudent choice in setting up a QPL of products. The second part is we are aware of some of the discussions going on complexity of near field photometry or near field effects versus far field photometry, given the common mounting distances between the luminaire and the canopy. And we are interested in respecting that as best as possible, but also where there are not yet standards that address those details directly, we're proposing a given approach here in the hopes that that is incrementally better than nothing. So we're aware of some of those technical concerns as well. I will admit that we are getting questions much faster than we can respond to them. We are also a couple of minutes over time here at the moment. So Damon, I think with your blessing here, I would like to suggest that if you have additional comments that haven't been addressed here, particularly if they are clarifying questions, if you would email us at info@designlights.org and note that you are really seeking some clarification if there's something that you are unsure about, so that you can provide useful commentary and feedback on the overall proposal, that would be worthwhile. We'll also go back through the questions in the report that we generate from the GoToWebinar interface and try and address the most common questions in a public way so that people can reference where the clarifications are. Does that sound good?
Sounds great to me. Thanks so much for your help in managing the questions. And thank you, everyone, for your time and attention today. We really appreciate your feedback, and we know that with your help, we're going to make the specification and technical requirements very impactful. With that, I believe I'm going to go ahead and sign us off, and please keep an eye out for future communications from us regarding the open questions that Dave referenced before, and just overall engagement efforts that are proceeding with our specification development. Thank you, everybody. Have a wonderful day, and talk to you soon.